Stop. Look at this pixel. It's not a glitch. It's not a dead pixel. This is the dark side of Proxima b. This planet is tidally locked. That means this side has been in total darkness for billions of years. No sun, no heat. So, why is there a light? James Webb just sent back thermal data that defies nature. It detected a concentrated heat source on the night side. Volcanoes don't look like this. Lightning doesn't look like this. The spectral signature matches artificial LED illumination. NASA calls it a technosignature. I call it a city. If this data is correct, we are not just looking at life. We are looking at neighbors who are awake, electric, and watching us back. Here is the evidence NASA is trying to explain. To understand the gravity of this data, you first have to understand the violence of the system itself. Proxima Centauri is not a steady, nurturing yellow dwarf like our Sunday. It is a class, men dwarf, a red star, much smaller and cooler, but infinitely more volatile. For decades, astronomers argued that life here was impossible, not because of the planet, but because of the star's temper. MEM dwarfs are prone to superflares, explosions of magnetic energy, thousands of passapas, times more powerful than anything our sun produces. In 2017, for instance, Proxima Centauri released a flare so massive it increased the star's brightness by a factor of 1,000 inches, mere seconds, bombarding the planet with enough UV radiation to sterilize a sterile laboratory. This is the environment we are dealing with, a chaotic, angry furnace that subjects its planets to constant X-ray torture. Because the star is so cool, the Goldilocks zone, the region where water can exist as a liquid, is dangerously close to the star. Earth orbits 93 million miles from the Sun, a safe distance. Proxima b orbits just 4 million miles from its host. It is locked in a gravitational vice grip, completing an entire year, a full orbit in just 11.2 Earth days. This extreme proximity comes with a heavy price: tidal locking. Tidal locking creates a world of binary extremes that is terrifying to contemplate. Mid-infrared spectrum. To James Webb, heat is light. It can peer through dust and gas to measure the thermal emission of an object with unprecedented precision. The mission utilized the MIRI instrument, the mid-infrared instrument, which operates at wavelengths capable of detecting faint thermal glow against the blinding glare of the host star. The mission plan was to perform a detailed phase curve analysis. As Proxima b orbits its star over those 11 days, it shows different faces to the telescope. By meticulously measuring the infrared light over the course of a full orbit, scientists can map the temperature of the entire planet. They expected a massive spike when the day side faced us, representing the scorched rock under the sun, and a near-zero flatline when the night side turned into view. That is what the laws of thermodynamics demanded for a rock in deep space, but the flatline never came. When the dark side of Proxima b rotated into Webb's field of view, the MIRI instrument picked up a discrete, high-intensity thermal signal. This was not a general warmth spread across the hemisphere, which might suggest a thick atmosphere redistributing heat. It was a point source, a concentrated dot of heat, roughly the size of a large metropolitan area on Earth, radiating temperatures far above the frozen background. The data was checked 3 times. Was it a background star behind the system? No. The signal moved in, perfect synchronization with the planet's orbit. Was it a sensor ghost or a pixel glitch in the MIRI detectors? No. The signal persisted over multiple orbits, remaining constant in intensity. We were looking at a localized heat source on a world that should be frozen solid. In astrophysics, when you find a heat source where none should exist, you have to rigorously rule out two natural culprits: the atmosphere and the geology. The first theory scientists attempted to apply was atmospheric superrotation. On some tidally locked worlds, like Venus or heavy super-Earths, massive hurricane-force winds can whip around the planet, transporting heat from the day side to the night side like a global convection oven. But the fluid dynamics and the math simply do not hold up for Proxima b. For superrotation to effectively heat the dark side to this degree, the planet would need a crushingly thick atmosphere. We see the heat, but we don't see the smoke. We don't see the chemical fingerprint of a geological rupture. We have a massive energy output with no volcanic exhaust. This leaves us with a paradox. We have ruled out the star warming that side. We have ruled out the wind carrying the heat. We have ruled out the planet bleeding heat from a volcanic wound. When you remove the wind and you remove the volcanoes, you are left with the impossible. You are left with a heat source that is stable, clean, and concentrated. It is a source of energy that maintains a high temperature against the vacuum of space without emitting the chemical byproducts of geology. If nature didn't put that heat there, then who did? To answer the question of who or what is generating this anomaly, we must fundamentally change the way we look at the universe. For the last 60 years, the search for extraterrestrial intelligence, known as SETI, has been handicapped by a single limiting assumption: the search for biology. We have spent billions of dollars and decades of computer processing time looking for the chemical byproducts of life, such as oxygen, methane, and water vapor. But biology is quiet. A planet covered in moss or teeming with simple bacteria does not emit strong signals. It does not modify its environment in ways that are easily visible across the vast distances of light years. To find a civilization, specifically one capable of lighting up the dark side of a star system, we shouldn't be looking for their biology. We should be looking for their pollution. This is the new frontier of astrophysics known as the hunt for technosignatures. It is based on a premise that is far more robust than biology because it relies on the immutable laws of physics rather than the vagaries of evolution. The most fundamental of these laws is the second law of thermodynamics. This law states that you cannot perform work, whether that is building a skyscraper, running a supercomputer, or heating a massive habitat against the cold of space without generating waste heat. There is no such thing as 100% efficiency in the universe. Energy that is used to power a civilization does not just disappear. It degrades into infrared radiation and radiates away from the source. On Earth, we see this phenomenon in our own urban heat islands. If you look at thermal images of Tokyo or New York City from space quantity, volcanoes do not spew freon. Lightning storms Studying CFCs would tell us that they are not just surviving on the planet, they are actively managing it. This moves them from a primitive society to a Type 1 civilization on the Kardashev scale, masters of their own planetary energy. Then, there is the nature of the light itself. This is the smoking gun that separates a natural fire from an artificial bulb. Natural light sources, whether they are stars, lava flows, or forest fires, emit what is called broadband radiation. The light is spread smoothly across a wide range of frequencies, creating a predictable curve on a graph known as a blackbody spectrum. Artificial light, however, is engineered for efficiency. It is narrowband. When we build LEDs to light our cities, we don't want to waste energy emitting light in invisible spectrums. We focus the energy into very specific, narrow wavelengths of visible light. This efficiency creates a jagged, unnatural spike in the spectral data that looks nothing like a natural curve. The data from Proxima b suggests a spectral bump that is suspiciously narrow. It implies a light source that is peaking in the blue and violet ranges of the spectrum, far more intensely than a natural heat source should. A team of astronomers has calculated that if a civilization covered just 0.5% of the planet's surface in high-efficiency solar panels or LED-based artificial lighting, James Webb would detect it exactly as we are seeing it now. We are likely looking at the collective glow of a megacity, a sprawling grid of artificial illumination designed to banish the eternal night. This is not the flickering, chaotic light of a wildfire. It is the steady, cold, engineered light of electricity. However, there is an alternative theory that fits the data even better than a city, and it is perhaps even more awe-inspiring. We might not be looking at lights on the ground at all. We might be looking at mirrors in the sky. To survive on a tidally locked world, a civilization would struggle to transport energy from